Okay, I think it's recording now. So welcome guys to our first session. Yeah, usually my videos are a bit longer, but I'm gonna try to split it up. So that's why I decided to start with pointers. Yeah, that's why I decided to start with pointers. Let me see. Is it really recording? Oh, I'm just tripping. Okay, yeah, it is recording. So yeah, let's start. So it's gonna be quite a journey, but not a very long journey, but let's start. So I'm gonna need to demonstrate because I need you guys to understand what's going on, right? So I'm gonna create a new project, console application, C++, because we're doing C++. So this is gonna be a tutorial on pointers. So we're talking about pointers, people's worst nightmare. But then it's not really that bad. You see just now it's not that bad. Okay. Okay, that's fine. Let me let me try to fix something here. Hmm. Okay. Wait, what's the status bar? Okay, yeah, I don't need that. I don't need the status bar. And then perspective, let's see, minimal. Yeah, this should be fine. I don't need all the extra stuff. If I want to build, I'm just gonna go here, build and run. I just want the minimalistic code blocks, right? So let's start. What are pointers? In simple terms, pointers are just an address. That's there's nothing fancy about it. It's just an address. So what do I mean by an address? So let's see, not arrows. Uh, okay, I genuinely cannot demonstrate, but it's like okay, just try to envision what I'm trying to have here. So it's like this. This is an address, right? Okay, this should work. Sometimes you have to be creative and work with the tools that you have because I wanted a house. So what happens is this is you, right? This is you, right? This is you. Let's say call him, let's call him let me see, what can I call him? Let's call him Light from Death Note, Light Yagami. So let's call him Light Yagami, right? So imagine this is you, this is your name, right? And where do you stay? You stay inside a house, and then this house has what? It has a what? It has an address, right? Where you stay. For example, if you're going to visit your friend and then you want to know where your friend stays, you need to know the location, right? Send me I think they say send me the Eddie or something like that. The slang for it, but yeah, it's like send me your address, right? Send me your address and then so that I know where you stay, where you are located. So the computer works in a very similar way. So if you go to this address, what do you find? The thing that you're looking for. In this case, it's a person, it's an object, right? So what the way a computer works is that we have all these shelves, right? You can imagine these shelves are like drawers. That's exactly how they are. They're like drawers, right? So we have all these shelves. I'm just gonna generalize. I don't want to go into the nitty and gritty, too much details, like how many bytes or bits and things like that. Yeah, just imagine we just have these drawers, right? It's just there's boxes, or you can view them as boxes if it makes things simpler for you. So each box, right, it has an address. Each box has an address. Usually, okay, yeah, it's most of the time it's in hexadecimal. Hexadecimal, you should see it on your slide just to get a bit of an understanding. But then hexadecimal, right? The reason for having hexadecimal is that, okay, I need to sort of like give you a background about coding. So coding in general, what are we doing? in coding, you might say C++ is hard, but it's not really that hard. So the way coding works is that the computer of the language is very complicated. The language of the computer is 0 and 1, right? 0 meaning that it's off, right? 1 meaning that it's on, like your switch. If you look at inside your room, when you switch on the switch, right, the lights go on, right? You switch it off, the lights go off. You coincidentally you might notice that some switches have a 1 and a 0. It depends on where you're located, what type of switch you have. Coincidentally, some switches have a 1 and a 0, which just means on and off. Why is it on and off? Because a computer, this computer that you have, before you use it, what must you do? You must charge it. You must charge your laptop or computer, right? Or PC or whatever you want, whatever that thing is, what any device whereby electricity is required, right? You need to charge. So that charging your laptops, it now has what we call current. It has current or electricity, right? That's what your laptop now has. So since it has current or electricity, the question is how can we represent data? So coincidentally, since a computer has electricity, it can either have electricity or there's no electricity. For example, in your room, the lights might either be off or might either be on because you're using electricity. The same applies with your computer. So you might ask, okay, I understand the zeros and ones. Now, how do we represent information inside the computer? We might have a sequence of ones and zeros like this. Maybe let's say this one means hello, right? And then this one means hello, Jack, something like that, right? So if I was to write this in the language of the computer, it would be like this. I need to combine all of the words, right? Like this. This will just be hello, but then I need some space in between, so I would have to put the space there. So it will be hello, Jack, right? It will be exactly like that. So what happened is programmers noticed that, okay, this is annoying. Why should I have to write zeros and ones? I'm not a maths guru or something like that. I'm not that. I mean, some of them are, but then the human memory or the human brain is not built in that way. We associate everything in terms of labels. Oh, you're wearing Nike. Oh, you're wearing Gucci. Oh, you shop from Woolworths. It's like that. Oh, you're drinking Coca-Cola. Oh, you're living a nice life, hey? And notice everything that you're saying, it's using words, not digits. So that's where the problem was. So what happened is they ended up creating what we call programming languages, right? So programming languages, right? So why was there need for them to create programming languages? Because it was too damn difficult to speak the language of the computer. And another thing is our language is ambiguous, right? It's very confusing. One word can have multiple meanings, right? Yeah, if you know idioms, if you remember idioms in English, right? If you remember idioms in English, you can say something that means something else. For example, you say it was raining cats and dogs. The problem is if we write in our own language, right? It doesn't matter what language it is, whether it's French or Zulu or Swati, any language that you're writing in, the computer will be very confused because it's very confusing. We have things like idioms, it was raining cats and dogs. So if you're the computer, the problem with the computer, right? Imagine a computer is basically someone who's very logical. Imagine trying to talk to someone who's very logical. They won't understand your perspective. And you are an emotional person. They won't you feel like they're inhuman, right? They don't have any sympathy for your emotions, but that's just how they are. They view things in terms of, oh, it's either true or false. That's exactly how a computer works. So it will think, oh, it's literally raining cats and dogs. So you see, that's why it's a problem. We cannot use our own language to code or to write, to tell the computer what to do. Remember, all we are trying to do is tell the computer what to do. Okay, allow me to upload pictures online. That's an instruction. You're telling the computer what to do, and then it uploads for you. But then if you're commanding it like this and say it's raining cats and dogs, it'll be like, okay, it'll go outside and look for cats and dogs. If they're raining, it might pick up cats and dogs and throw them in the air. And then the cats and dogs will start falling down. Then it'll be like, oh, now it's actually raining cats and dogs. Because computers are literal. They take everything you say literal. Imagine that person, wherever you make a joke and then they just take it literal. That's like a computer. It's logical, it's literal. It doesn't want any ambiguity. Don't try to use idioms and things like that to confuse it. So what happens now? We've noticed that we can't use the language of the computer, and we can also use English, right? So in simple terms, right, it's like you have this, right? Two people are trying to communicate with each other. We'll get to addresses and pointers. I just wanted to explain what's going on. So we have the machine, which is your laptop or your phone, and then we have you, which is the future software engineer who's gonna work at Google. That's you, right? Software engineer, right? That's you. You're trying to communicate with that person, right? This is the person you're trying to communicate. This this is you trying to communicate that person. Imagine it's a very stubborn person. It's like, nah, me, I'm a machine. I only speak machine code. It's actually called machine code. The language of the computer is actually called machine code. Language of the computer, right? So it's actually called machine code. So this person is like, nah, it's gonna be stubborn. No, I only speak Sotho. That's the only language I speak because, yeah, my ancestors were of this and that. Imagine you have a stubborn person like that. So the issue here is that, and then you have another person who's like, nah, me, I'm Swati, right? I can only speak Swati. I don't speak English. I don't speak Zulu. I don't speak Tsonga. I don't speak any other language. I only speak Swati. You have these two people, right? They're trying to communicate with each other. This computer says I only speak in my language, which is machine code. This software engineer, which is you say you only speak in English, but then your language is flawed, right? Because it includes a lot of things like idioms. Some words have multiple meanings. The computer is a literal person. Its language is very literal. So what can we do to bridge this gap between the two people? They can both come to an agreement and like, okay, let's invent a language that's easy for you to understand, and it's also unambiguous. So that means there's no confusion. You can't get confused, right? So that's what happened. This okay, let me not okay, let me put this person there. So this is what happened. The people were like, oh, okay, it's fine, we'll invent a language. And then they invented a language, right? And then this language is called programming language, right? That language is called programming language. Why? Because you program with it. You make programs, you make apps. Program is it's another word for app. It's a synonym for app. So you make an app, right? So and that the thing that you use to make an app, let me put it this way, the language that you use to program a program or to program an app, we call that a programming language because you are using that language to program, to make a program, to make an application. And this language takes a bit of both from these sides, right? It's similar to English. Okay, we're just gonna assume everyone speaks English worldwide, right? So we can't say, okay, let's put Afrikaans. That's unfair. Some people cannot speak Afrikaans, so it's something like that. So they had to choose English because majority of the times a lot of textbooks are translated are written in English. So Yeah, it's like a basic thing. Whether you're doing it as a first additional or a home language, at least you have English as one of the languages in your toolbox. So that's why they chose English. So we have that language, right? So now the problem is that this person can understand, right? You can understand because it's similar to your language. But then it also has these traits of being straightforward. There's no ambiguity. There's no, okay, it's raining cats and dogs. It will go straight and say it's raining. If it has to say it's raining water, it will say it's raining water. Straightforward. You don't have any idioms. So the computer won't get confused because remember, we are trying to command this person to do something, which is the computer. So after having the programming language, the problem is the 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 problem is look at the problem. I'm gonna write this program inside using a programming language, right? So that programming language the computer still cannot understand because the computer speaks in zeros and ones because it's powered with electricity. If you were a computer and you're powered with electricity, you'd be speaking in binary or in machine code, which is the language of the computer. You'd be a machine, of which, lucky enough, you're not a machine because, yeah, you don't speak in zeros and ones, right? So the problem is it cannot understand. So what happens is now we need what we call a translator, a person, a middleman who's going to translate now. This is going to be a translator or interpreter, or in terms of programming, we call that a compiler. That's what it's called in terms of programming, right? So we have all this going on, right? So what's going to happen is this person here, right? This guy over here is going to write in a C++ program. This translator or compiler will translate it, and then the machine code will understand, oh, this is what you mean. You want me to draw a flag, or you want me to send this message to another person. Okay, I understand. So you just notice when you just remember when you do anything on a computer, even a phone, you are sending something, it has to be translated. Even if it's a message to your friend on WhatsApp, it has to be translated. So this is the process that goes on. So as we are here, we need to understand this programming language so that we learn how to tell the computer. Because if you fail, remember what the translator will do. It will try, if you don't, imagine this is a translator who's very strict. If you don't use, for example, you don't start your sentences with an uppercase, it'll be like, okay, this is wrong. What's this? Like, what's going on? Why did you start with why did you start with a smaller letter? The small letter I. Why did you do that? You know the rules says you should start it with I. That's why most of the time when you don't follow the rules in a language, you get errors. So in code blocks, when you're getting those errors, it's like I'm confused. I don't know what you're trying to say because you failed to follow the rules. So you need to follow the rules so that the translator doesn't face any issues with translating. And then it translates the computer, it finally understands what you want it to do. So yeah, with that being said, we have a bit of an understanding of what's going on. We have a bit of understanding what programming is, right? So let's fast forward and now go to pointers. So what happens is in programming, right? Everything that you do, it lives somewhere. It stays somewhere. Just like you right now, are you not somewhere? Are you not in a place? You're in your room. Whether you're at your friend's place, you're still in a room. You're somewhere. You're at a specific address. That's where you are. Always remember that you had a specific address. So what happens if I say int, right? Int number, right, is equals to 10. What I'm doing is I'm telling the computer, listen, I want you to create a box for me that only stores integers. If you remember in high school, when you have something like this, X is an element of Z, right? Z meaning integer. If you remember in high school, in your maths class. So this is what we're talking about. It's integers. So from negative to positive infinity, but then the numbers are integers, right? It's not like decimals whereby it's like 1 point. There's no such. It's integers, if you remember integers. So what this thing tells the computer, it's like, okay, create a box, right? That can only store integers, right? And then you're also telling it, when you say is equals to, you are doing what you call an assignment operator, right? Operation. So assignment meaning you are assigning, you are assigning. Imagine like you are the boss, right? And you assign everyone their role. So that's literally what you're doing. You're assigning this box a value or giving it a value. So you're literally going inside the box and putting in the value 10. So you can only store integers, and then you tell it to go inside and put 10, the value 10 inside. In other words, you're doing this. So let me put that down a bit. In other terms, you're doing this. You are creating this box here. And then you see the name of the variable number. It's a label. You're putting a label there, and then it's now called number, right? That's the label of the box, so that you know which box to so that you know which box you're referring to. If imagine you just put random things in a box, you won't know, right? That's the thing. I would like you guys to picture it in terms of the real world. If imagine having a box and it has no label, you put random things there. There might be some thing there, family members pranking each other and TikTok these days. There might be something there that will blast when you open it. So that's why labels are very important, right? Or it might be something that you're not looking for. Imagine you're in a garage and there's 100 boxes and you're looking for a stapler. You're looking for a lousy stapler. The box has no label. You take the whole day trying to find that stapler. But then if you had a box that was labeled staplers or stationery or something that relates to a stapler, you'd be like, oh, it's in that box. So that's what's going on here. So what happens is, let me see, can I, okay, let me see if I can, okay, no, it don't work. But what happens is when you say is equals to 10, it's like you are telling it to go put the value 10, which is this one. So it puts the value 10 there, right? But then remember, you've told the computer that this box only accepts integers. So if you try to put things like strings, you start facing problems. So let's just do that. And don't normalize not putting this like this as it is. It will try to interpret it as code, but then it doesn't know what to do. So if you want to make it a comment, you just do this. Just put 2 forward slashes so that it knows, okay, ignore this line. It's not code. Just ignore it. That's what that comment tells it. So imagine you're trying to do this number is equals to hello. It's gonna scream at you. Let's build. You see, at exactly that line. So what I'm going to do is, okay, yeah, I don't like this, but I want you to see the error. So you see, sometimes the error is very confusing. It says conversion from const char pointer to int. Yeah, remember C++ is derived from C. So in C, this is how you'd create a string. So let me show you what this error actually means. In C, you'd create a string like this. Char pointer, right, and say greet, and then say is equals to hello, like that, right? Let me build. Okay, yeah. So this is how you'd create a string normally. So they made it easier for you guys. Then they just said, const char, it's very complicated. Let's call it a string, right? So this compiler it's actually using that rule from C now. It's like, oh, it failed to convert a const char pointer to int. So it's like, okay, in simple terms, like, okay, this box, you told me that it can only accept integers. How does it know? The data type. Remember, data type just means what type of data should go in there, should go inside the box. So you've told it that it's only accepting integers, but then out of the blue now you're breaking your promise. It's like you've promised it everything that I'm gonna put inside this box with that label number is going to be an integer, and then you went against your promise, and then it's gonna remind you that wait, you didn't fulfill your promise. So yeah, just keep that in mind. That's how variables are. So now we understand variables that they're just boxes, right? But in these boxes, you can imagine they're piled, like they're piled up, right, on top of each other, right? But before, there's a lot of things that happen, and I'm trying to make the video short as possible without, because I know you guys are gonna look at the video and be like, nah, it's too long. But then I'm explaining everything. But let me try to cut it short. So this box, right, in order for it to be allocated inside your, in order for you to use that variable, right, this box, whatever, you need to create space or what I call memory, right? Memory, you can imagine it's like a location, it's like land. Okay, this is my land. So put this box in on that on top of that land. This is where it stays, right? Remember, each land has an address, right? Before you build a house, it has an address, right? So each of these boxes inside of here, they'll have an address. And an address would be anything, just an address, literally an address. But then in terms of computers, right? Come on. So in terms of computers, right? Addresses, they are in hexadecimal. They start with OX, meaning that it's in hexadecimal, followed by any numbers, right? That would be the address. So when you create the variable number, it's going to have its address there. If I create another variable, it will have its own address. So each variable or each box, if you want to put it that way, each box or each container is stored on your computer in a specific location where there's an address. So now you might ask yourself, how do you retrieve that address? How do you know? Are you sure that it has an address? Yes, I am sure. So let me minimize this. Yes, I am sure it has an address. How do I know? We can use the address of, which is the ampersand, right? Or the and symbol. It's called another term for it is called address of. Address of meaning get the address of this box or this variable. That's what it means. Let's demonstrate. So I can say C out, right? And then say address of number like this. And then you're gonna see it will show it in hexadecimal. It will start with 0x. Let me build and run because I want to see my output, right? So it should show now. It's a bit slow. Yeah, so you see it starts with OX, meaning it's in hexadecimal. So for those who are curious about what is hexadecimal, why do we have those decimal systems? Remember, it uses zeros and ones, right? Since it uses two digits, zeros and ones, two digits, 0 and 1, we call this the binary number system. Binary number system meaning that there's two. Bi means two. So there's two binary numbers, right? There's two numbers. So there's many number systems, right? I'm just gonna paraphrase it, just don't go into too much detail. We have the numbers that we have been using, we use the DEC system. DEC meaning 10. DEC, literally the word DEC means 10. So DEC or decimal number system, DEC or DEC, which meaning 10. By 10, what do I mean? I mean 10 values. So by 10, by the number of values that I mean the number of values that you use to represent any number. Any number. We actually use 10 values. So let's count. 0 is 1, it's the first number. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 including 0. So we have 10 numbers to represent any number. You don't believe me? Let's check it out. Let's make an example. Let me say 931. How many digits did I use here? 3. I used the 9, 3, and 1, which is within this decimal system. So that's what it means when they say DEC, and that's what it means when you say binary. We are saying you can only make use of 2 values to represent any number or anything in general. So after this, we have what we call the hexadecimal. Hex, look, just pay attention. Hex meaning 16. So there's 16 values or numbers that you can use to represent any number. Let's see. It's actually like this. Look at the word. It's a hexadecimal. Look, decimal. So it improves the decimal number system, which is our number system, and adds extra information. So how does it add? So it's 0, this, and then when you get to 10, right, you start counting using letters. Use A, B, C, D, E, F, and then that's pretty much it. And if you count, remember these are 10 digits, right? 11, 12, 13, 14, 15, 16. You see hexadecimal, 16 digits to represent the number. So now when you look at our address, look, don't we have an F there? Don't we have a C there? We have a C. So don't be confused by this thing. The OX, right? The prefix OX, it just tells it just helps the computer remember that, okay, treat this number in a special way. Treat it as a hexadecimal. Remember the X in there as hexadecimal, meaning 16 digits that are used to represent each number. So yeah, that was quite a lot to explain. I hope you can understand what I'm talking about. So remember, each box or each variable has an address, and we've retrieved the address this way. But then sometimes it gets annoying, this thing of always having to retrieve address, retrieve address, retrieve address, retrieve address. Isn't there a way where we can store both? Because why am I saying both? Remember, I can get the address by using the address of, and I can get the number by just omitting or removing the address of. I get the number, right? I get output. So let me run it. I get actual number. So what happens is when you output the name of the variable, right? It goes to that address and finds a box with that label at that address. So it's actually doing a lot of things behind the scenes. You just don't see it. You see, it goes to that box. If you see the output is 10, right? Which is expected because our box has a value of 10 and it's at a specific address, right? You can imagine an address as like your house address, right? So now it's always, you see, it's always annoying. If I want to output the value, I remove the ampersand or the and. If I want to output the value, if I want to output the value, I remove the ampersand. If I want to output the address, I add that ampersand, right? Or the address of operator. You see, it's a bit cumbersome. It's a bit annoying to keep doing that back and forth. Isn't there a clever way to combine these two? I can still get the address and I can also go to that address and get the content of that address. Basically, when I say go to that address, I mean go visit your friend. Remember, you asked your friend for the address and then you literally went to that address. So let's create a point. So with pointers, right, they're trick. They're very trick. You see, with this, right, with numbers, right, or with normal data type variables, right, and you're using normal data types, you can initialize it to 0. This one is a pointer, so you say int, right, and then I say, let me call it num, right? You can't just leave it like this. This is very wrong. It's very dangerous. If you leave it like that, it's going to definitely give you an error. Because remember, it's a pointer. You can't just point, right? You can't output an address that's not there. we can't output anything if there's no address, because there's no address to go to begin with. So you be confusing the computer when you say, okay, output this when you haven't initialized it. So the way you initialize it, right? You have to give it an address. Remember, it's a pointer. A pointer in simple terms, right? A pointer, it's a way of storing the address, right? But then what they don't really tell you is that you store both the address and value. Both address and value. Both of them inside one variable. Remember this previously, to find the address, we'd have to use the ampersand. You had to use all of those things to find the address. With pointers, there is. So let's see how to initialize them. So to initialize them, you have to get the address of some other box, right? Or there's many ways. You can make it have no address. How do you make it have no address? You just set it to null like this. Or you can use null pointer. It's one of them should work. So what this means, it means it's not pointing to anything. It has no address. That's what it means. It hasn't been initialized to any address. But then I want to initialize it to some address. So if I say it's equals to number like this, it's going to complain, because it's going to be like, okay, what do you mean, chief? What do you mean when you say it's equals to number? Did you forget that I'm a pointer? Did you forget that I'm an address? So since I'm an address, no pun intended. Since I'm an address, you need to address me the right way. So address him the right way. What do I mean by that? He needs an address. So I need to get the address of that variable, right? And then I've initialized it now. So why do we have this thing is like, it's so weird, right? It's very weird, right? Trust me, it's not weird. Let's analyze it. So with the pointer, right, when you write it without, you see, without the asterisk, right? Without that thing, you actually get the address, which is the location, which is the same as saying address of some variable. So if you use the pointer without this star, not me thinking about TikTok trends, Watashi wa star. Yeah, if it doesn't have this star, then it's no longer Watashi wa star, right? It's no longer like a star anymore, right? It's no longer a pointer. So if it doesn't have that thing, it's no longer a pointer. So if you're only referencing to it without the star, then it's an address. You're referring to an address. Let's verify. So I'll show you now. I'll say cout and then num, right? You see, it's much easier than having to use address of and things like that. I just use it without the pointer, and then I automatically have access to the address. So if I build and output this and run, right, I should see output. So let's wait. That's why I said I need to split it up, because there's a lot to say. There's a lot to cover. Okay, let's not pay attention to the number. But then if you remember very well, this is the same number we got last time when we used the ampersand. So you see now it's like a bit easier to use the pointer, because I don't have to continuously use the ampersand every time I want to get the address. So now how do I get the value? This is where the star, the Watashi wa star, comes into place. So this star, right, what it does, or what it tells the computer, it means point to that address. In layman's terms, or in simple terms, it means go to that address. So basically, go visit that person at that address. In simple terms, right? I want to use the analogy of a person, right? You're visiting your friend. So this is you now visiting your friend. How do you visit your friend? Remember, this is the address. So this is the address, right? So let me do it the right way. So let me do this. Remember, this is our box, right? This is our storage, right? Where everything is stored. So we have our box at that location, right? And then we have that number there, like this. And then it has a label. So when I use the pointer, what in essence what I'm telling the computer is I'm saying go to this address, go there, point. That's the whole point, no pun intended. That's the whole point of it being called a pointer. It means point or go to that address. So how do I go to that address? I just use it like this in full. So I use the pointer, it means point to this address. Remember, this would be OX something, right? This would be an address. So remember when it outputs an address, right? So when it's like this, right? When there's the pointer there, it means go there, point there to that address and take what's inside that address, which is in essence what's inside the box, right? But then remember, okay, this since we're using num, I'm not using number, I'm using num, right? So point to this num variable, which stores the address, right? So go to this address, point to that address, go inside it, right? So since you literally visiting your friend, is at that address, you point at that address or you go to that address, and then what do you expect to find inside the house? You expect to find the person you're planning to visit, right? You don't expect to find um Peppa Pig when you're visiting your friend, right? That's weird. That's why I'm saying if you point to that address, you expect to find that value. So I hope it makes sense because students get confused with pointers a lot. I don't see the need to get confused. So point to this address. Here I'm outputting just the address. And then this is just the number before, right? This is just the number. So I can just remove this, comment it out so that you can see my output. So let's see the output. Okay, it's loading, it's taking its precious time. So there we go. You see what I'm talking about? This is the address right here without the pointer. That's why I say without the watashi wa star. It's no longer a star, right? It's no longer you can't find the star itself, which is the person themselves, right? Unless you go to that address. So all you have is you can imagine this is just the address written on a piece of paper. That's it. So you haven't found the person. That's why you can only see the address because you've written down on a piece of paper. And then if you point to that address or go and visit the person you plan to visit at that address, you find that thing you're looking for, which is at the value 10, right? That's pretty much it. That's all you have to know about pointers, right? For now, that's all you have to know about pointers. So we know we can get values, we can change values and things like that. Let me see how long the video is now. 43 minutes. I know you guys don't like long videos, but you see, there's nothing I can do at this point. I'm trying to make the videos as short as possible. So we have C out that we have, yeah. So now let's try to change the value, right? Let's try to change the value. So this is before, right? So before, and then I'm going to put an end of line character. So let me output so that you see what I'm doing here before I make any changes. It's going to output the before on its own and then the numbers, the other information below. Yeah. So this is before I've made the changes, right? This is me before I've made the changes. Now let's output after. So see out after, right? Remember, we need to add a new line character so that the cursor, which is this thing that keeps on blinking, so that it moves to the next line. This just makes it move to the next line. So we have after, right? The title after. So now we can make changes to our point. How do we do that? So we have, in order for us to actually see the change inside of my memory, right? I need to tell the computer, okay, listen, declare another variable or another box and then give it a new address, right? It's going to give it don't worry, it allocates the addresses for you. You don't have to allocate the address. All you can do with the address is just retrieve them. That's all you can do. You don't have to do anything. So we're going to have this box here, right? It's going to have that address, whatever address it has. And then within that address, we're going to have a box with the label. So basically, it's going to have there's going to be a new address. So let me say int a is equals to 100, right? Let's change the pointer, right? Let's update the pointer. There's many ways to go about it. There's many ways. I don't wanna lie, there's many ways. So the first way, which is gonna be the easiest way, is for me to remember the name of the variable itself, it represents the address. So num, if I look at num, I'm actually looking at that address. So point to, meaning go to that address, which is stored with that label num, and change the content. Remember, you're going inside the house, right? So this is like you literally going inside the house, removing an item from your friend's house and replacing it with another item. Which item is that? Which is just A. So I'm going to replace it with the value of A. Remember, it's value because I've pointed or I've gone inside the address or to that address or to that house. I'm inside the house, right? I've gone to that address. I'm inside the house. So obviously, inside the house, I have access to the objects themselves. I have access to the microwave, to the teaspoon, to the what. I have access to all those things. That's why there's no need for me to use address of day. Here it was fine. You see here it was fine because I needed to initialize it to an address. Because how does it know I'm initializing? Because it's so this is the first time me declaring the variable or the point. It saw that then it was like, okay, you can't just declare without initializing it. Initialize it. So that's why it was expecting me to provide an address. So now let me see. This should build. Let's try to build. Okay, no issues. So it is built. We've went to that address, and then okay, let me think of a scenario. Imagine you went to your friend's house, and yeah, imagine you went to your friend's house and you saw his PlayStation, right? Okay. Let me not use an example that not a lot of people can relate to. Imagine you went inside your friend's house and you know he's not a fan. He's definitely not a fan of Pepsi. He's a diehard fan of Coca-Cola. And then you go to that address, right? This is his address. You point to or go to his place or his address, which means where the house is located. So you go inside the house. You replace his Coca-Cola, of which that's what he has inside the house. Imagine his fridge is full of Coca-Colas. You replace all of them with Pepsis. So in this case will represent Pepsi, the thing that I want to add to that house. So now I'm expecting num to be different, right? Let's check it out. So I need to output twice, right? The number and the address. So remember, without the pointer or without the star, it's just an address. So this would be the address. And then this would be the content or the things that are stored at that address since I'm pointing to that address. So I'm going to build and run. You're going to see something miraculous. Okay, this didn't go as planned. Interesting. I don't know why I didn't do that, but then, oh, okay, I see. I understand. I understand what happened. So what happened is it's still at the same address, right? But I didn't. Okay, think about it from a logical perspective, right? You went to that address. You only changed the thing inside that place, right? That's the only thing you changed. Did you move the house to a different address? Nope. So that's why the address is going to be the same because it didn't move the house to a different location, right? It's still at the same address. If you wanted to remove or change the location of the house, now I'm showing you a second way to change the variable. You could, in essence, just relocate the whole house or relocate the person in the house, whatever way you want to view it. But then just no addresses are changing. That means this person, yeah, let's view it in that way. Just imagine the person is moving out to a different house. So remember, without the pointer, it's an address, and I want to change the address. So I need to leave it like this. And then I need to say address of, because if I just leave it as that, it's going to try to get the value. So I need to say the address of A, where this variable is located in memory on my laptop. Right, let's just try to build and see if it's going to compile well. Okay. Okay, let's try and build and run. Okay, perfect. So now you see now there's a surprise here. The address now officially changed, right? We can see it has changed. This means this person has relocated. But look at the content, the things that are inside. He no longer has Coca-Cola, he now has Pepsi. Why did it change when I didn't change the value? All I did was relocate. It makes sense. Remember, when you relocate, you get furniture. Imagine you have a house with the house you're relocating to, it already has furniture inside. And the furniture that is in the new house might not be the same as the furniture in your old house. So by default, if you move to that house, let's say you're moving, by moving, I mean you now own it. That means you have access to this new furniture or this new thing that came with the house. I don't have to physically um, move new furniture. I just found the furniture there. So that's why pointers are very important or crucial for you to understand. You see, I only changed the address, meaning I relocated, I moved. Let's say you're staying in the rural areas and then you move to the suburbs. Now you've made it. You're screaming, Mama, I made it. You're there playing Caspanyo verse. Mama, I made it. You're like, yeah, I'm out of the ghetto now. I've made it. So you've relocated, right? So you previously had few furniture, like let's just imagine the number just represent the count, which is the number of items you have inside the house or furniture that you have. Now you have 100. You're like, wow, I'm him. I'm here. I've made it. So automatically you get access to the things that you find in that house. If you relocate and move to a fully furnished house, it comes with the property, with the stove, with the microwave, with the fridge. So I didn't have to actually change and go inside the box itself. I didn't have to go inside NAM itself, the box itself, and change it. All I did, you see what happened here? Let me show you what happened visually so that you can picture it. I changed the address. By address, I mean it means this person moved here. He moved there. Okay, I don't know why it's doing that. Okay, it's not allowing me to. So let me drag and drop another box. So you moved there. You've relocated, right? This is a different address. So this is an address, right? A different one. Let's say OX1, 2, 3. Yeah, something like this. This is a different address. The name is still the same, right? You still have this num. I don't know why this thing keeps doing that. I need to keep dragging and dropping new things so that it's able to visually appear on the box. So what happens is you move to that new address. That 10 is still there. The 10 is still there in that location, right? Or it's non-existent because okay, technically it's still there in the previous house. Yeah, technically it's still there. Don't wanna lie, it's still there. But then now you've relocated, you've moved, this box is moved to this address now. And this address, it came pre-installed with 100 items or the value or the integer 100, right? It came with that extra furniture and you're like, wow, I get to keep all of this. This is all for me. This is free. So that's why when you see the addresses, when the addresses change, the content itself automatically change because you moved to a new apartment or a new place or a new house, and it came with different furniture. So there we go. You see the addresses are different. It has changed because you've relocated. And when you relocate, even the things that are found in the house are now different. You're in a different house. That's why, for example, when they say when you visit, when you go to a person's, when you visit your friend's place, don't be too comfortable because those are not your things, right? And they're not the same, right? The spatula is not the same. The plates are not the same. The glasses are not the same. The fridge might not be the same. It's different property, right? So obviously that's why this value, the content at that address has changed since I've relocated. I've moved to a new address. I hope it makes sense. I am hoping it makes sense. If it doesn't make sense, I guess I'll try to explain a bit more. I don't know how more I can explain because I try to make it as simple as possible. Just let me know if you guys really understand, but then I try to explain. Without the pointer, it's just the address. When you combine the two, the name of that pointer, which is num, and the pointer itself, the star, you are now pointing or going to that address. So basically, you're accessing the contents of that box. So I'm pointing to num inside the box. Go inside the box. What do I find? 100. So that's why when I see this line of code, I'm expecting it to output 100, of which it does output 100. There we go. It does output 100. Everything's fine. So I hope this brought some clarity. And if you have any questions, just let me know. Okay, I'll see you in the next video. I'll also, if you did understand this, then I'll also go through function pointers. Function pointers is basically the same thing as pointers, right? It's an address, right? It's addresses, all of them is just addresses involved. So, but then now we're working with the addresses of where the functions are stored. So see you in the next video.